This is the another model. Look here. This is the uniform rod. This rod length yellow. This rod mass M. This rod is bent in this method here. Is bent at midpoint. At midpoint means this length is L by 2. This length is L by 2. Okay. Here find the common center of mass. Here this angle also given this angle is theta. Okay. Find the common center of mass from O or from midpoint. 1 minute this is the uniform rod. Uniform rod center of mass is center. That means this length is simply called as L by 4. This is another rod. I arranged another rod. Actually, this is only one rod, but it is bent at midpoint. It can be considered as 2 rods. This is one rod. This is another rod. This length also L by 2 because it bent at midpoint. So here this is the center of mass L by 4. This is C1. This is C2. Center of mass of the first rod. Center of mass of the second rod. According to mathematics, common center of mass present here. Okay. C12 this can be determined from origin. Okay. If this total angle is given theta, automatically this angle is called theta by 2 because total angle is theta. This can be considered as theta by 2. Here one perpendicular line is drawn. Same diagram I drawn here. Look here. This is the perpendicular line. Perpendicular line. This line, perpendicular opposite line is called hypotenuse. This is called opposite because this is the angle here. This is the opposite. This can be considered in the mathematics adjacent. In the diagram, look here. This is the perpendicular line. This line opposite. This is called what? Hypotenuse. This is theta opposite side. This is called adjacent side. Here, this adjacent side can be calculated because find the center of mass, common center of mass from origin. This can be considered as X. Okay? X value can be calculated. According to diagram, this side is called what side? Hypotenuse. This side is called adjacent. So that's why in the mathematics, cos can be taken as cos means adjacent side by hypotenuse. Here cos theta by 2 equal to what is the adjacent side in the diagram? X. That can be calculated. Hypotenuse write as L by 4. What is the X value here? L by 4 cos theta by 2. Okay. Next method sixth problem. Look here, sixth problem. 3 identical spheres, each of radius r, are placed on the horizontal surface, touching one another. Keyword in the problem: all spheres touching one another. Indaga third problem I rasam. Adenti ante all centers joining in one line. Kani idela undi ante these 3 spheres touching one another means in this arrangement is here. This sphere touch, this sphere touch, this sphere. All the spheres will be touched. That means on the horizontal surface, 3 spheres touch each other. Here, each sphere radius is considered as R. Okay, here also R. Here also R. Okay. Here an equilateral triangle is formed. Equilateral triangle is formed because this side length is 2R. Here that means same diagram I drawn here. Side length actually L, it write as 2R. Equilateral triangle is formed. In the equilateral triangle, center of mass concept. Center of mass always lies at centroid. Centroid, any corner ఎంత డిస్టెన్స్ ఉంటుంది సార్ అంటే L by √3 ఉంటుంది. ఇదిగో సెంట్రాయిడ్ నుంచి any side perpendicular distance between any side ఎంత ఉంటుంది సార్ అంటే L/2√3 ఉంటుంది. ఇప్పుడు నాకు కీవర్డ్ ఇన్ ద ప్రాబ్లం నాన్న వన్ ఆఫ్ ద స్పియర్ రిమూవ్ చేయమన్నాడు. వన్ ఆఫ్ ద స్పియర్ బీకేసాను, నేను ఈ పైన స్పియర్ బీకేసాను. వన్ ఆఫ్ ద స్పియర్ రిమూవ్ చేస్తే కామన్ సెంటర్ ఆఫ్ మాస్ హియర్ ఇక్కడ ఉంటుంది, ఎందుకంటే బోత్ ఆర్ యూనిఫామ్ నాన్న. సెంటర్ హియర్ ఇక్కడ పాయింట్ ఆఫ్ కాంటాక్ట్ సెంటర్ ఆఫ్ మాస్ ప్రెజెంట్. దట్ మీన్స్ నాన్న in the equilateral triangle generally previous concept centroid ఇక్కడ ఉంది, ఇప్పుడు సెంటర్ ఆఫ్ మాస్ హియర్ టు హియర్ షిఫ్ట్ అయింది. ఎంత షిఫ్ట్ అయింది అన్నాడు, ఇక్కడ నుంచి ఇక్కడికి రావాలి అంటే ఎంత షిఫ్ట్ అయింది, ఇదిగోనన్నా చూడండి హియర్, ఇందాక ఇక్కడ ఉంది ఇప్పుడు ఇక్కడికి షిఫ్ట్ అయింది. ఎంత షిఫ్ట్ అయింది అంటే సెంట్రాయిడ్ టు ఎనీ సైడ్ ఎంత లెంత్ ఉంటుంది అంటే L/2√3 నాన్న. ఆల్రెడీ సైడ్ లెంత్ ఆల్వేస్ 2r నాన్న. Here right side length is 2r by 2√3. 2 to what? Cancel. Finally we get r/√3. Okay. Next problem we discuss another model. Seventh problem. Most important problem. Here the question agenda is, this is the sphere. Its sphere radius is given capital R. Sphere radius is capital R. Its value is 1 meter. Okay. Here a sphere of radius 0.5 meters. A sphere of radius 0.5 meters is removed from the edge. That means ఇది ఒరిజినల్ స్పియర్ నాన్న. దీంట్లో some parties remove. Some parties remove means nana, here look here nana. Here this part is removed nana. This part is removed nana. This part is removed. Here in this part radius is given 1/2 meter. 1/2 meter. Here actually one sphere nana. Here the question is a original sphere, some part is removed. Okay. Actually original sphere taken as a first body, removed part taken as a second body. Once again I repeat, original sphere taken as a first body, its mass is m1, and again removed part is a second body. For example, this question is sphere nana. Sphere is a 3 dimension. For example, 3 dimension means mass depends upon the volume. Okay. Here, for example, given body is a circular disc. Mass depends upon the area. Okay, because circular disc is a 2-dimensional body, and again the body name is square. Square also 2-dimensional body. On the situation, mass depends upon the area. Simply called as given body 2-dimensional body, mass directly proportional to area. The given body is a 3-dimensional body, mass depends upon the volume. Here this is the 3-dimensional body because this is the sphere, so I take volume. Volume of the sphere write as 4/3 pi r cube. Okay. Here nana, here also 4/3 pi r cube nana, but here radius is half nana, r/2 whole cube. Here look here, this is r value 1 meter. Here r value 1/2. 1/2 means it's r aithe automatic ga idemoutundi nana, r/2. Okay. Here look here nana, this is r/2. For example, here r value 1 meter. This removed part is small r anukunte given is 1/2 meter. Or here write small r also. Here a large sphere radius is capital R. Removed part radius is small r. 4/3 pi small r cube. And again I take x1 nana. This x1 means always measured distance from first body center to origin. Here I assumed origin is here nana. So this is the original sphere. In the original sphere is origin is here. This original sphere center also here. Both are coincide. distance between origin to first body center is 0 because both are coincide. X2 means distance from origin to second body center. Origin to second body center. Here to here length enta 1 meter. Okay, 1 meter. Here to here length enta 1 by 2. Remaining length enta 1 by 2. That means 1 by 2 meter. You understand? Once again I repeat nana. Origin to second body center. That means removed body center. Here this distance can be equal to 1 by 2 because here to here 1, here to here 1 by 2, remaining is 1 by 2. Here the question agenda is here one part is removed. In this case, remove. To see the question remove, axiom formula is m1 x1 minus m2 x2 by m1 minus m2. Here minus when that only removing is seen in the question, minus can be taken. What is the axiom formula? m1 x1 minus m2 x2 by m1 minus m2. According to question, m1 value simply call as 4 by 3 pi capital R cube, x1 value 0 minus m2 value simply call as 4 by 3 small r cube into x2 value 1 by 2 all by below 4 by 3 pi 4 by 3 pi r cube minus 4 by 3 pi small r cube. Here 0 into anything 0. Here finally neatly write as denominator 4 by 3 pi 4 by 3 pi cancel. Here neatly write as minus r cube by 2 into here also r cube minus r cube. But here according to question capital R value 1, small r value 1 by 2. Here substitute now. Here substitute small r value 1 by 2. 1 by 2 cube 1 by 8 into 2 into capital R value 1, 1 cube also 1. 1 by 2 whole cube 1 by 8 minus 1 by 8 into 2 into 1 minus 1 by 8 7 by 8. 8 cancel nana. Finally we get minus 1 by 14. Okay, minus 1 by 14. This is the final answer nana in this problem. Next, this concept nana, look here. All of you look here. This is the balloon nana. Balloon. Here, this is the thread nana. Thread length is L nana. Here monkey is there. This monkey is moving one end of the string to other end of the string. Here one body says a action, other body says a opposite reaction according to Newton's third law. Here monkey moving upward, balloon moving downward. Balloon moving downward. Here monkey moves one end of the string to other end of the string. Here to here nana. Simultaneously balloon moving downward because of Newton's third law or law of conservation of linear momentum. Here distance moved by the balloon is y nana. Directly I give the formula small ml by small m plus capital M. Here small m indicate mass of the monkey nana. Capital M indicate mass of the balloon nana. L is nothing but the length of the string or monkey moved distance. In the other situation, look here now. This is the wedge nana. This is the wedge nana. This is the black nana. Black. Here black mass small m, wedge mass capital M. Black moving downward nana. That means black moving in this direction. Wedge moving opposite direction. That means here black moving one direction, wedge moving opposite direction according to Newton's third law or according to law of conservation of linear momentum. Here capital Y indicate distance moved by the wedge nana. Formula is small ml by small m plus capital M. Here small m indicate mass of the black, capital M indicate mass of the wedge, okay, inclined plane OR. Okay, next question this is the boat boat mass capital M, boy mass small m. Boat length is here L here L, here also here this is the length of the inclined plane is L. ఇక్కడ ఏంటంటే L అంటే ఏంటంటే this length this length, okay, wedge length. Here look here here also boat length entante L. Here boy moves one end of the boat to other end of the boat boy moves one direction, boat moves backward direction according to law of conservation of air momentum. Here also y means distance moved by the boat is equal to small m into capital L by small m plus capital M. Okay, what is the y small m into L by small m plus capital M. Here small m indicate mass of the boy, L indicate distance moved by the boy, small m indicate mass of the boy, capital M indicate mass of the boat, y indicate distance moved by the boat. In the three situation one formula is there, that is y is first case distance moved by the balloon, in the second case distance moved by the weight, in the third case y is nothing but the distance moved by the boat. Okay, here this eighth problem is given problem is question I can explain a balloon of mass capital M okay, this is the string here man is there man mass is small m this man moving here to here what is the velocity of the balloon can be determined. Velocity of the balloon can be determined. Man moving upward, balloon moving downward, what distance? Small y formula is ml by m plus m. Here distance we know that, but here identify, here asked the question is velocity. We know that in the first year displacement by time is called velocity. That means both side I apply differentiating with respect to time. D by dt of y equal to d by dt of m L by m plus m. Okay, here displacement by time is called velocity. This is the velocity of the balloon. Here common term is constant is common. Small m by small m plus capital M. dl by dt. Distance by time is called velocity. This is the velocity of the boy Here this is the formula This is the formula between velocity of the balloon and velocity of the boy or man. Here man moving upward, balloon moving downward. In this situation, balloon moving downward with a velocity is small m by capital M into velocity of the man or velocity of the boy or velocity of the monkey. Next problem.